Hi everyone. We are presenting fifth place winning solution to Kaggle COVID-19 detection competition. Our team is Ayushman, Nishya, Shivam. So as you can see, we finished fifth place on the leaderboard with a score of 0.628. Agenda of this talk will be background about ourselves, summary of the solution, preprocessing method, training methods, important and interesting finding, and in the last, important link. So background about ourselves. I myself is a data and applied scientist at Microsoft with a working background in data science field, and I graduate postgrad. I am postgrad from IIT Kharagpur. Nishya is second team member who is undergrad in electronics and communication. He is a competition master with 3 gold medals, 12 silvers, and 4 bronze medals. Ayushman is a third team member who is also undergrad student in computer science engineering and has been a student intern at IIT Guwahati. About the summary of our solution, our winning blend was consisting of 16 classification models, which was on 4 different architecture. We also used 2 different architecture binary classification models, which were 5-fold models. And in the object detection models, we used 5 different architectures of 5-fold models. In the final leaderboard, our private LB was 0.628 with the 5th place, and in the 3rd place in public it was 0.649. Pre-processing method which we used in the competition was converting DICOM files to PNG images and then resizing it to 1024, keeping aspect ratio same. We also removed duplicate from the data as discussed in the forum. We extracted mask using VBox labels, which was provided in the competition data. And we did stratified k-fold, group stratified k-fold to use it in the further training. About training methods, Ayushman will be talking about.
Thank you, Shivam. So for our study models, there are basically classification models. We train different variants of EfficientNet models. The models that we used are EfficientNet V2M, EfficientNet V2L, EfficientNet B5, and B7. For regularization, we use segmentation as auxiliary loss in all the models. We also use different classification heads for the models, and many of them had attention in them. The main things that worked for us was noisy student training, and during testing, we also used horizontal flip as test time augmentation. Next slide, please. For our binary classification model, that is the model which predicts none classes, we use an EfficientNet B6 model. Here also we use segmentation as auxiliary loss and horizontal flip as test time augmentation. We also use noisy student training method to improve the model. Now Nishya will take over.
Thanks, Ayushman. So coming on to the object detection part, as you could also see in the block diagrams, we used an ensemble of 5 different architectures with 5 models each. Some of the models we trained were on public test data pseudo labels, while other ones were trained on just competition training data. So you could also see the model names we used for training in the PPT. Yeah, so talking about some important findings, we tried our best to combine study and image level models and try ensemble strategies. So for study level, we simply took the weighted mean of 16 different model predictions for each class based on the fold-wise results. While for image level predictions, we noticed that none predictions are highly correlated with study negative for pneumonia class. So we combined some of the study models in ensemble for none predictions too. Weights of all these ensembles mentioned were solely determined by the validation score and diversity. Yeah, coming on to the post-processing part, it gave us a good amount of boost in both our hoof score as well as leaderboard. So as we didn't use any end-to-end solution and trained most of our models separately, so the idea behind using post-processing was somehow to consume the binary predictions for no finding and detection model confidence score in a form of ensemble. So as you could also see, we took the power blending for improving no finding predictions and also replaced some of the opacity confidence score for each bounding box. You could also visit some of our important links, which includes our GitHub repo for solution or our Kaggle post.
Thanks, everyone.